Hello, welcome to this BrodieMaths video about transformations. I'll be talking to you today about reflections, but rotations will also be mentioned. So now we're looking at reflections. Here's our shape again. We might be asked to reflect the shape in the line y equals 2. So let's find y equals 2 first. Y equals 2 is that line there, because everywhere along there the value of y is 2. So we need to draw that line quite clearly. There's the line y equals 2, and we're reflecting that shape. The best way to do this is to look at how far away each point is. So that point is 3 points from the line, so it has to be 3 points below the line. So that's matching that corner. That corner is 4 points, so it's going to be 4 points below. 1, 2, 3, 4 points below. This one is 3 above the line, so it's going to be 1, 2, 3 below. That one is 1, 2, 3, 4, 5 above the line, so we need to go 1, 2, 3, 4, 5 to get to there. This point is 5 above, so 1, 2, 3, 4, 5, 5 below, and we've got enough now to be able to draw the reflected shape. There it is. That is that shape reflected in the line y equals 2. Now, what if we wanted to reflect that shape in the line y equals x? Now, remember that the line y equals x is where the y value matches the x value. So let's look at that. So x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, x is 10, y is 10. So we've got enough points there to be able to draw the line passing through the origin. Now, this is a much harder thing to reflect in, but if you look at that corner that we looked at first before, perpendicular to the line y equals x, it's half a square away. So it's going to have to be half a square away there now. That's that corner matched. This one is 1 whole square away, so it's going to be there, 1 whole square away. This corner is 2 whole squares away, so 2 whole squares away is going to be there. That one is 1, 2, 3 away, so 1, 2, 3 away is there, and you can see now the shape is appearing. So there is that shape reflected in the line y equals x, and you can see the sort of symmetry there. It's like a mirror line, and it's reflected across the mirror. So let's call the original shape A. You may be asked, what has happened to it to be mapped onto shape B? So shape A has been mapped onto shape B. You need to use the word reflection in the line y equals 2. A is mapped to B by a reflection in the line y equals 2. Now, what about A to this one, which not surprisingly we'll call C? What's happened this time? C is a reflection of A in the line y equals x. Notice you need to use the word reflection, and you need to say what it's reflected in. Where is the mirror line? So it's a reflection in the line y equals x. Now we're going to look at a reflection in the line y equals x again, and this one's quite a tricky one. Let's find y equals x. Well, 1, 1 we know is the same, and well, let's go straight up to 10, 10. So we've got 3 points. Always good to have 3, but we've got the origin plus 2 other points, so now we're drawing the line y equals x. Y equals x, I'll write that on. And we've got to reflect this shape in it. It's overlapping the line. But let's have a look at what we've got. I'm going to start with that corner there. That's 2 squares away. So 2 squares away is going to be there. This one's 1 square away, so that's going to be there. This one is 1 square away, so that's going to be there. Now look at this one. It's half a square away, but in the opposite direction, so that's going to be there. And that one's actually on the line, so it's going to be there. And look what's happened. Here is the reflection. It's overlapping in both directions. And you can see we've ended up with a very symmetrical shape again, but it's overlapped the line in both directions. It's a reflection in both directions. Now I'm going to reflect this shape twice. I'm going to reflect it in the y-axis, and then we'll have the reflection. I'm going to reflect that in the x-axis. So let's have a look at that. First of all, in the y-axis, the reflection. And you can see that that point is 2 away, and that point is 2 away. That's a good reflection. So we're going to call this one, well, let's call that one A, and we'll call this one B. And now we're going to reflect B again, but this time we're going to reflect B in the x-axis. So it's going to be careful with this, but the numbers sort of get in the way. That's 1 away, so 1 away is there. So the reflection comes down here. And that is shape C. Now, a question that quite often comes up in the exam is, how do you get from A to C with one transformation? Is there a single transformation that will map shape A onto shape C? Well, as you probably have guessed, there is. So, the single transformation that will map shape A onto shape C is not a reflection, it's not a translation, it is a rotation. And on this occasion, it's going to be about the origin. So the origin is the center of rotation. Using my pencil to hold the tracing paper still, I'm going to rotate the shape, and it lands exactly on C. You can see it just landing there. So to map shape A onto shape C using a single transformation, we can say to map A onto C, a rotation of 180 degrees, and it could have been clockwise, but the way I did it was anti-clockwise, so that's fine, about the origin. So we are specifying that the origin is the center of rotation. Thanks for watching.